So I want to tell you a story about Flagstaff, and although it's going to have some discouraging parts at the beginning, and I know it's not going to be news for most of you, I want to use that as background to help us realize, first of all, that we have a problem and why we have a problem. And there are some aspects to that which I don't think are widely understood, which I want to touch on, critical aspects. And I also want to give the story of that we know how to solve this. And not only that, we have proven how to do it. We have a demonstrated case study on the ground that shows that what we think we know about solving this problem is a practical and real solution and has real results. So, you've all seen this image. This is an atlas from a portion of an atlas of the world taken from a paper published in 2016, the second world atlas, or called the New World Atlas of the Artificial Sky Brightness, published by led by an Italian group with Fabio Falchi, based on satellite observations taken in 2014. It shows a discouraging picture of the world, and particularly in North America, illustrated here. Any place on this map that has a red color or brighter in the urban areas that you can see scattered across the country has a sky that's too bright to see the Milky Way from that location. Though it does not look like a large area of the map, and in fact it is, it's a small fraction of the land area. In fact, it's where people live, of course. Now, people can travel and do travel to the dark places on the map, and the DSI Dark Sky Places program has focused very much on raising awareness of the value of darker places, even in some of the darker places in the eastern areas there, where you see some areas that are green or blue colors, but in the dark black areas in the west. But overall, where people live, the Milky Way is no longer a nightly experience. And further, despite us working on this for 40 years now, at least dating this effort from the founding of DSI or IDA in 1987 and then incorporated in 1988, we've been at it for 40 years. Why aren't we making progress? Are we making progress? And if not, why? So, besides the data which I just showed you that was showing that almost 80% of the North Americans cannot see the Milky Way where they live, when there are observations made looking upward from the ground, a little bit more reliable prediction of what's actually happening, with eyeballs counting stars, it turns out it's getting worse, and it's getting worse quickly. This was observations based from 2011 to 2022, and the results indicate that the sky is getting brighter by about 10% per year. That means it doubles every 7 to 8 years. What's going on? We know it can be better. We understand the basics of what's going on. We've been talking about it for decades. Here is a demonstration that it can be better. Here is a measurement made in 2016 and published at an American Astronomical Society meeting in 2017 in Texas, turns out, where we use the National Park Service night sky camera, which maps the brightness of the entire night sky from horizon to zenith and 360 degrees around the horizon, showing Flagstaff, Arizona, and Cheyenne, Wyoming. I don't mean to pick on Cheyenne, Wyoming. It just happens to be an ideal example already in the observations made by the Park Service, because they have a park unit that's located about 31 kilometers outside of Cheyenne, Wyoming, which turns out to be very similar to the distance we made the observation for Flagstaff. And we mapped the brightness of the sky. Now, Cheyenne, we were actually a little farther away than Flagstaff, 31 instead of 27 kilometers. And Cheyenne is a little smaller at that time, 63,000 versus 70,000. Both of those should have helped Cheyenne look fainter. But in fact, Cheyenne is brighter, and it's not a little bit brighter. If Cheyenne is 100 units of brightness, Flagstaff is less than 10. Now, there's other images on this map of Fort Collins on the right and Phoenix on the left of Flagstaff. But comparing the domes of light over Flagstaff and Cheyenne, it shows that we have a path forward to make things better. But we knew this. We should have known this. I should have known this. I did a study in 2003 where I looked at Flagstaff lighting. I did a comprehensive survey of all the lighting in Flagstaff, not counting every fixture. There's tens or hundreds of thousands of fixtures, but sampling them and estimating the total amount of light. And I determined that there was some overlighting, and if we reduced the overlighting, we might improve the brightness of the sky by about 25% if we just address the overlighting. I have a feeling that's worse today, but I don't have any numbers to measure it, to document it. So let's stick with 25%. If we shield lights, if we stop shining the light up into the skies, and we've all been thinking about this one for 40 or plus years, it turns out that nearby you drop the brightness of the sky overhead by about 50%, and that's a stunning improvement. Farther away, if you're miles away from the light sources, turns out that's even the fractional improvement is even better. But let's stick with 50% because that's where people live, near the lights. The next one is spectrum, and that compares what happens if you use typical lighting, favoring white lighting, particularly nowadays. It was not quite so popular before LEDs were on the ground. But you switch to what Flagstaff was using at that time of amber source. You have an even greater improvement nearby, and that is a 70% improvement. If you combine all three of these together, that leads to a 90% estimated improvement in the brightness of the night sky. And indeed, that's what we see in this image, very close to it, a 91% improvement. So that confirms this measurement, and the estimates from modeling and the theory line up. So this is what it looks like. Let's go on the ground a little bit. This is a photograph of the city of Flagstaff taken from a mountain we have overlooking the city. You can see, of course, much of the city laid out at our feet there. You can see a lot of the amber lighting. There's a lot of amber hue in that lighting there. But further, you can see the Milky Way overhead. And this is not a composite image where the sky has been processed differently than the landscape to reduce the contrast and allow the Milky Way to be seen. The magic you can do with Photoshop. This is a single shot. So let's go back and look at what happens when we apply this kind of lighting process, this kind of lighting standards to all of North America. Remember this image in 2014 where 78% could not see the Milky Way where they live. We know it's gotten worse because it's been about 10% per year between 2011 and 2022, I think it said on that previous image I showed you. So let's update this for current data. And you can see, if I go back again, look at the dark areas in the western US, you'll see that they get smaller. Now, let's assume that this is typical poor shielding, which we know is rampant across the country in most places, like Cheyenne, but not just Cheyenne. And much of it is dominated by white lighting. Not exclusively white lighting. There's decorative lighting, there's neon lighting, there's some high pressure sodium, which is an amber light source. But overall, dominated by white lighting. Now, what would happen if we just shielded the lights? Look how much it improves. That's the 50%. I go back and then forward again. Watch the western US, it's obvious, but even in the eastern US, you can see the spread of the light pollution has decreased and the brightness overhead has dropped by about half. But this is still white lighting. This is important. It's 3000K CCT, which in many venues is the recommendation for dark sky protection. Let's see what happens if we go farther. Now remember I said that switching to an amber spectrum is an even greater benefit than what happens when you shield, as dramatic as the shielding improvement is. This is what would happen to the US if we all switch the majority of our outdoor lighting, not all of it, but the majority of it, to lower impact amber lighting, kind of like high pressure sodium used to be. And we're not going to go all the way to the best lighting in amber. This is what the North America would look like. This is supported by the observations of Flagstaff and Cheyenne. It is supported by the research papers. This is what we should be aiming for. Again, I said, we knew it could be better. The papers that have described these benefits have been on the ground since the mid-'80s, and several papers I did in 2003. Actually, that was a presentation at an IDA annual meeting. And then in 2009, 2014. This stuff is more than 10 years old. It's not new information. And I want to draw attention to the one most neglected standard, and that is the amber standard. Look here. The 70% or greater improvement by emphasizing the use of amber lighting in the outdoor environment. It is the most important strategy. It is more important than shielding from the sky glow perspective. I have to admit that as I got into this from an astronomer's perspective, I thought a lot about the brightness of the sky and visibility of stars. And there are many other impacts to light pollution, and I'm sure all of you are aware of many of these. There's glare, there's trespass, and shielding is beneficial for those glare and trespass much more to a large degree, even though amber also reduces glare and trespass as well. But I want to keep in mind that I'm focusing on one of the principal measures, my principal focus of dark sky protection, and that is darkness of the sky and visibility of stars. And when I talk about amber lighting, I am not talking about low color temperature white LEDs. Across the top here you see 3 spectra showing blue to the left and red to the right of different wavelengths and the intensity emitted by the lights up and down the graph in the various wavelengths. And you can see all of the white LEDs on the top from 5500 Kelvin white to 2600 Kelvin white all have a significant amount of blue and green light. And we're going to talk about why that's a problem. What I'm talking about for amber is one or both of the light sources on the bottom, which have essentially no blue and little or no green at all. And by the way, here's Chris Luginbuhl's I Can't Resist It lecture to my colleagues, if there are any in the audience who are physically inclined and have been talking about why is this blue and green light bad. People talk about it all the time and it drives me nuts. So forgive me if I diverge a little bit to talk about this. It's not Rayleigh scattering. It's not Rayleigh scattering. Astronomers like to think of this as Rayleigh scattering because, well, it's kind of our topic. And there's such a strong dependence on wavelength for the amount of light that's redirected in the atmosphere, that's scattered by the molecules. It's proportional to the inverse wavelength to the 4th power. My gosh, that's very strong. But in fact, if you actually do the modeling, it turns out when you're nearby, those blue sources do indeed get a little bit brighter than the yellow sources. You can see here, paper was done before LEDs were the standard of choice. There's a few LEDs over there, but mostly there are other sources, but they're similar. The cool white lights, the LED 5100 Kelvin, the metal halide, there's a FLED, which is a filtered LED, and a low color temperature LED. All of them get a little brighter when you're nearby, but less than 10% brighter, less than 5% brighter. Your eyeball would not even notice that. And once you get further away than 5, 10, 15 kilometers, the blue sources are actually fainter. If you're measuring all wavelengths or looking at, if you're looking wavelengths based on the way we define lumens, and that is the photopic response of the eye. So if it's not Rayleigh scattering, why are these blue and green sources brighter? Because indeed they are brighter. They are a lot brighter, but it's not physics, it's biology. You all have seen curves like this. Here's a wavelength graph across the bottom from the near ultraviolet on 350 on the left to the deep red 700 on the right nanometers, and intensity goes up. And this is what the sensitivity of the daytime eye looks like. And this is not just the daytime eye in the room you're in now or out in the sunny landscape. It's also the eye response in the nighttime illuminated environment. We're very sensitive to We have color vision because there are 3 different kinds of cells, and we're most sensitive to light at about 555 nanometers. That's a yellow-green color. But at night, when we're looking at the sky, not at the parking lot, not at the illuminated roadway, not at our dashboard of our car, we are looking at the sky. Even in light-polluted cities, our eyes become scotopic, and that is much different sensitivity. That peaks about 505 nanometers, significantly bluer, and is overall not very sensitive to yellows and reds compared to the daytime vision, which defines the lumens and foot candles. So this is why this is important. Here are a sampling of lights that we use, 2 on the bottom with lots of blue and green. One of them is metal halide, which is kind of obsolete now, although there's still quite a bit of it in sports fields and service stations. And a white LED on the bottom. They have lots of blue and green, as you saw in the graphs I showed earlier. They are very good at stimulating our vision across in the daytime. The amber sources, in this case high pressure sodium and narrow band amber on the top, that real narrow amber spectrum for LEDs I showed earlier, they are not quite at the center of sensitivity, but they're still kind of 70–80% sensitivity. They are good at providing visibility in illuminated environments. But when you shift to dark adaptation, look what happens. You still see plenty of blue and green light. They've got just as much energy to offer your eyeball when you're looking at the night sky. But those amber sources have shifted now way away from the peak sensitivity of your eye, and you can hardly see that yellow light bouncing back out of the atmosphere. That's why amber sources are much fainter, cause much less sky glow than the blue-rich and green-rich sources. And by the way, notice it's not just blue, it's blue and green. That's why, and that's not just a little bit better. Remember I said less than 10% when we're talking about the photopic daytime response? If we shift it to our nighttime response, this is what happens. And this is where that dramatic increase in light pollution from the broad spectrum light sources come from. Look at 3000K CCT, the favored standard in dark sky standards nowadays. It is 5 times as bright as low pressure sodium on the bottom, and I know that's an obsolete source now, but that's essentially the same as the narrow spectrum amber light LED as well. It is 5 times as bright simply because of the different photosensitivity response we have when we're adapted to the dark. Even if we go down to very low color temperature, 2400 Kelvin, we are still 3 times as bright as these amber sources. The amber, if we go to one that looks like HPS, that one that was on the previous graph on the left side, what we call a phosphor converted amber, that's about twice as bright as the low pressure sodium or narrow spectrum amber, and the narrow spectrum amber is reference point here of 1. So that's where that dramatic increase in light pollution comes from those broad spectrum sources, not from Willy scattering. And thank you all for bearing with me while I lecture my colleagues, if there are any in the audience. We all love to say Rayleigh because it sounds so sophisticated, I think is what our problem is. Anyway, so let's go back now and talk about what this means on the ground if we applied these standards, including amber, to the visibility of the Milky Way. We talked about it in 2023. This is the more or less estimate of what it is nowadays. You've seen this, I showed you this graph before. Here's where we already in 2014 could not see, 78% of the people where they live could not see the Milky Way, and it's gotten worse since then. I don't have an estimate for how much worse, but significantly worse. It's probably about or more than doubled in brightness. This is what happens if we apply the Flagstaff solution lighting. Amber lighting for most outdoor lighting, like roadways and parking lots and security lighting. You still use white where you need it, like outdoor sales or sports fields or service stations. but you favor amber lighting like we used to do everywhere when high pressure sodium was the favored light source, not very long ago. In fact, I think high pressure sodium may still be approximately 50% of our area lighting out there, roadway lighting. But good shielding and amber lighting takes 78% cannot see the Milky Way where they live to only 24%. We have brought the Milky Way home to more than 50% of the residents of North America. That is like 170 million people would have the Milky Way come back to their homes where they could experience it every night when they stepped outside their back door. Yes, it is important to raise awareness about the value and beauty of dark skies, that they are a thing, that they exist, and that if you go to dark places away from your home in this current condition, you can still experience them and be awestruck by them. And you can become an astronomer if you're awestruck, or you can become a poet, or you can just have an improved quality of life, even potentially health improvements. But not everybody can experience this every night. Not very many can experience it every night, and not everybody can afford to travel to remote locations and take hotels at parks and enjoy the night sky. So restoring the night sky where we live, which is within reach, we know how to do it. We have the technology to do it. We know the techniques and the standards, brings equity back to the night sky, if I can use that word in this day and age. This is another way of looking at it. I'm sure many of you have heard of or seen the Bortle scale. And it's a semi-quantitative, qualitative description, and I don't want to get too much into numbers. But if we talk about urban skies being between 7 and 8 in most cases, particularly in the residential areas of urban cities, shielding will improve you by 50% and drop you down 2 Bortle classes. If you do shielding and low color temperature white, that'll improve it somewhat more. It'll get you down into 2.5 Bortle classes into the middle of Bortle class 5, but you will still not see the Milky Way. You need amber to do that. That is a critical standard that I hope you go away with, understanding that there is a critical shortcoming in the way we are approaching it, and we can restore the skies if we take advantage of what Flagstaff has learned. Not only do we know from the physics and biology of it that it works, but also by actually having built it on the ground, we know that all of those bugaboos that people worry about when they talk about amber. Oh, can you see color accurately? Is it more crime? Is it available? Is that technology available? Well, Flagstaff didn't know the answers to those questions any better than anybody else. But now the rest of you do know it better because we've done it. I don't know if Stephen Hummel might be in the audience here, and I hope he'll say hello if he is. I'm going to take advantage of some work that Stephen did, and Stephen is the Dark Skies Initiative Coordinator at McDonald Observatory. He was at Grand Canyon National Park as an astronomer in residence about a year ago. And during that time, he took some images from the north rim of Grand Canyon looking south toward the Phoenix area and Flagstaff. And you can see labeled on the map there the sky glow over Phoenix, 190 miles away, and the sky glow over Flagstaff, only 73 miles away. Notice that Flagstaff's glow is a little bit oranger, even though it's closer. Lights, by the way, they get yellow the farther away you go, just the same way that the sun becomes yellow and red when it sets. So that's what's turning Phoenix red here, probably, or not red, orange or amber color. But Flagstaff, even though it doesn't have the benefit of as much distance, is obviously not as is more amber. Now, he also made measurements with the national, I wanted to give a quote. He gave a report to the superintendent summarizing his assessments of the night sky condition at Grand Canyon. And I want to I'll read it to you. A brief quote from his report to the superintendent. The city of Flagstaff is not a significant source of light pollution as seen from Grand Canyon, despite its relatively large size and proximity. This is a testament to the successful efforts of the city and community partners to promote better lighting practices. He also made measurements with the calibrated camera system that the Park Service has, and he has one of those cameras as well. And on the top, you see the measurements made at Grand Canyon in 2015 by Park Service personnel. And you can see Phoenix on the right of that little ruler in the middle there, which we've superimposed on the image for reference. And just to the left of that ruler is the little glow from Flagstaff. Here, the other natural sources of light have been removed, the sky glow and the Milky Way. I put little bars sticking out of the ruler to show you the height of the sky glow for a reference in that top image. And Stephen repeated those measures just last February, roughly 10 years after the first measurements were made. And indeed, just like we've been seeing the bad news at the beginning of this talk, Phoenix has gotten significantly brighter. Unfortunately, the observation location is suffering, or Flagstaff is benefiting from the growth of a tree, which is now blocking much of Flagstaff, but Flagstaff did not get significantly brighter, whereas Phoenix got much brighter. That's proof that in this day of the last 10 to 15 years, when light pollution has been documented to be getting significantly worse, Flagstaff has avoided that fate. So what I hope I leave you with today is that there's a problem and there is a solution. Flagstaff has tested a lot of this. Sometimes I say that to teach you about gravity, I can approach it as a physicist might and teach you about all the background you need to understand Einstein's general theory of relativity and tensor calculus and all that stuff. Or I can just reach out, grab an apple, reach out over the floor and let it go, and it falls. And now you kind of know the basics of what gravity is. Well, for light pollution control, you can talk endlessly about how we need more research and what might happen to the economy, or is it safe enough? And really, are the products available? And you know, these questions, some of them are real questions, and sometimes we don't know the answers, and they oftentimes stymie progress. But on the other hand, we can say Flagstaff, with their 50 plus years of protecting the night sky, has basically dropped the dark sky apple. We took the risk, we dropped it, we tried these things, we used the awful, what the industry would call awful amber, low pressure sodium, and now amber LEDs. And we have shown that it protects the sky, produces a Milky Way visibility over a town of nearly 100,000 residents. We are just now completing the Flagstaff retrofit of approximately 3,000 streetlights to narrow spectrum amber LEDs, the highest quality, the gold standard in night sky protection. The Arizona Department of Transportation, of all companies, of all organizations, a state transportation organization, is just now commencing to replace all the lighting that they have on the interstates in the Flagstaff area, approximately 400 lights, with phosphor converted amber. So there are solutions, and I hope that we can all focus on really making the world better rather than just slowing the degradation. So I thank you for your time, and if there's time for questions, I'm glad to, if I can hear them, entertain them.
Thank you, Chris. We can take the mic to anybody who has a question.
Hi, Christian. My name is Susan Barnes, and my question is, how did you initiate this? Was this something the city initiated? How did you get all of the different partners on board? And do you have a white paper or research paper of some sort where you outline your process?
Okay, thank you for that question. Not everybody can be an expert in everything. One of the things that is critical to a successful application of good light pollution standards is, besides getting the standards, and one thing I want to push back on in general is that people should stop recreating lighting codes every time they go to their community with this idea that, oh, everybody needs a different priority. There are no compromises in Flagstaff's code. Everybody can see fine. So we need to stick with a good standard. But how do you get those adopted? And I think that may be more what your question is. How did we successfully get a community to confront these gremlins of fear and uncertainty, and I'll say industry resistance to a lot of this stuff. It's a long process, and it's built on community relationships. That's what these dark sky groups, such as DarkSky Texas, the chapters of Dark Sky International around the world, that's what in my view, their principal focus and value is, and that is engage your community broadly with the night in a positive way. Educate people, engage them in activities where they enjoy the night and learn that this is something that matters to them. And while they are enjoying the sky, maybe a star party, maybe even just an owl prowl, or going out and listening to frogs chirping in the spring at night, any way to get people to engage in the night, you will have opportunities to show people your passion, your interest, and that there are positive solutions that do not require somebody to do something that is not economical for their business or not safe for their security. It's a long slog, and you are never done with it. I've been doing this educational outreach for my whole career, for more or less 40 years, with increasing emphasis since I retired. And that's really something that's critical. You have to get out there and engage with everybody. Identify people who might be, or organizations that might be expected to be, or maybe have expressed already some skepticism or resistance, and talk to them. Well, I don't think I'm going to give away any secrets here to the group. We're right. This sky stuff is inspiring and valuable to everybody. It's not just for a bunch of, or a handful of crazy people who like to look at stars. It's all of us. And if you don't care about stars, and actually I don't think there's hardly anybody who doesn't care about stars, but if that's not your main thing, maybe you care about better sleep, or maybe you care about not having your neighbor shine a light into your bedroom or your living room. Whatever motivates you, there is benefit from every perspective to doing light in a way that protects the night sky. I hope I've helped you answer your question. It's not an easy process. It does require continuous engagement, and then as soon as you're done with one group, you kind of have to start over with the first group again.
So the questioner is shaking her head yes. Any other
I'm glad.
question? Yeah. Any other questions for Chris? You've got a great group here listening to you today, and we are so glad that you took the time to zoom in with us.
Well, I'm pleased at the opportunity, and thank you, Cindy, for reaching out and giving me the opportunity to speak with you and your group. Can you give me a sense of how many people do you have there?
We have close to 45 people here who are all advocates. They're people who have been working in conservation, and many of them working on specifically dark sky work. They're people who have worked on international dark sky places.
Right.
Yeah,
Right.
we have, it's basically an advocate education weekend.
One thing I'd like to make one small point at the end here, if it might wrap it up, and that is dark sky places are a great idea. I might say so myself because the Flagstaff Dark Skies Coalition initiated the program in 2001 with a proposal to the IDA, at that time, Board of Directors. And as soon as the Board of Directors accepted it as a good idea, of course, we turned around and nominated ourselves, and that's why we have this 25-year logo on my screen here. We've been the Dark Sky Place for 25 years, and the Dark Sky Place program is 25 years old. There are 270 approximately dark sky places around the world now, and they are hugely valuable for raising people's awareness that dark skies are a thing. Before IDA started, or DSI started, I don't think the word dark skies even meant anything to anybody. So really they've created this awareness. And dark sky places and the process involved in designating dark sky places is a critical part of this relationship building that I talked about just a moment ago. But many of these places are really seeking to identify places where the skies are already inspiring and dark because they're mostly remote. And that does not diminish their value, but it does not bring the Milky Way home where people live. The dark sky urban places, the dark sky cities, need to step up the game to help us bring the stars back where people live, because it can be done. Right now, most people who live in urban areas don't even realize how much better it can get if they do what Flagstaff has done.
And
So,
you're speaking to the right people here. Amber Harrison is here with us and here's here not only to interface with people and network, but she's one of our speakers after lunch.
oh, great.
Yeah, we've got good group, good group.
Well, I'm really impressed. 45 people, that's a lot. Good for you. It's a big state, so you have a lot of work, but it's a good job.
Well, yeah, we've got, that we have a lot of people who are doing good volunteer work, but they for various reasons could not come quite this far at
Yeah.
this time, but we'll move this around the state each year and have a various group. And we're also planning to put our videos out on our YouTube site to reach people that couldn't get here.
Where are you? What town are you in today?
We're in Fredericksburg, Texas today.
Okay. Well, good. I thank you again for your time.
Thank you so much, and we hope you have a wonderful rest of your weekend.
Well, thank you very much. Take care, everybody.
Take care. Bye-bye
Keep
now.
looking up.